Okay, we now do chapter 2, which is basically quadratics. And the first one is by factorization. The first section is by factorization. Solving quadratics by factorization. Solve x squared takes 7x plus 12 equals 0. Factorizing into x minus 3 times x minus 4 equals 0. We see that x is equal to 3 or 4. So 3 and 4 are the solutions to x squared minus 7x plus... So 3 and 4 are the solutions to x squared minus 7x plus 12 equals 0. Solve x squared minus 5x equals 0. We factor out x to get x, open brackets, x minus 5 equals 0. And thus x equals 0 or 5. So 0 and 5 are the solutions to x squared minus 5x equals 0. Solve x squared minus 16 equals 0. We apply the difference of two squares identity to get x plus 4 times x minus 4 equals 0. And thus x is equal to plus or minus 4. So plus or minus 4 are the solutions to x squared minus 16 equals 0. Solve 2x squared at 5x minus 3 equals 0. Okay. Factorizing into 2x minus 1 times x plus 3. We see that the solutions are a half and negative 3. So 1 half and negative 3 are the solutions to 2x squared at 5x takes 6 equals 0. Oh. Okay, my mistake. Try again. Solve 2x squared at 5x minus 3 equals 0. Okay. Yeah, so it's 2x minus 1 times x at 3 equals 0, and thus x equals a half. A half for negative 3. So 1 half and negative 3 solve 2x squared at 5x minus 3 equals 0. Correct. Hello! Okay, let me try again. So 3x squared minus 10x plus 8 equals 0. Okay, so factoring into 3x plus 2 times x minus 4, we get that x is negative 2/3 or 4. So negative 2/3 and 4, solve 3x squared minus 10x plus 8 equals 0. Alright, now completing the square. Write x squared plus 6x plus 1 in the form x plus a all squared plus b. Okay, so that's x plus 3 all squared minus 8. And thus a is 3 and b is minus 8. And that completes the square of x squared at 6x at 1. Yes, I have a huge forehead. Write x squared minus 10x plus 30 in the form x plus a all squared plus b. Okay. So the answer is x minus 5 all squared plus 5. So x minus 5 all squared plus 5 completes the square of x squared minus 10x plus 30. Hello! State the minimum value of x squared at 8x at 3. Alright. Now, one way you can do this is to use the line of symmetry and substitute this in. So the line of symmetry is calculated by minus b over 2a. In this case, that would be minus 8 over 2, which is minus 4. And then we can substitute that in. So we get minus 5. So minus 4 comma minus 5. So it seems that minus 4 comma minus 5 is the minimum of x squared at 8x at 3. Write 2x squared at 12x at 5 in the form of a times all of x at b squared plus c. Alright, so let's factor out 2. So we get 2 open brackets x squared add 6x add 5 over 2. We can just factor out 2 from the first pair of terms actually, in which case we'd get 2 open brackets x squared add 6x and then plus 5. And then we can do 2, and then inside the brackets x add 3 all squared and then minus 9. So we'd actually have to end up subtracting 18. And when we subtract 18 from 5, we get negative 13. So A becomes 2, B becomes 3, and C becomes negative 13. And that should complete the square of 2x squared add 12x add 5. Solve x squared minus 4x minus 1 equals 0 by completing the square, giving exact answers. Alright, so completing the square of the first 2 terms, we get x minus 2 all squared minus 4, and then we have x minus 2 all squared minus 5 equals 0, and then we have x minus 2 all squared equals 5. Square root both sides and add 2, so x is equal to 2 plus or minus root 5. So 2 plus or minus root 5 are the exact solutions of x squared minus 4x minus 1 equals 0 by completing the square. And root 5 is approximately 2.27, and thus one of the solutions is negative. Okay, next up, QF, quadratic formula. Solve x squared add 2x minus 5 equals 0, giving exact answers. So what we're going to do first is do the discriminant. And we get 24. Alright, and then it becomes minus 2 plus or minus root 24 all over 2. Root 24 is 2 root 6. So it becomes minus 1 plus or minus root 6. So minus 1 plus or minus root 6 should solve x squared plus 2x minus 5 equals 0. Yes, that's right. Okay. Solve 2x squared minus 6x plus 1 equals 0 with exact answers. discriminant first. And we get 44. So then it becomes 6 plus or minus root 44 all over 4. So 6 plus or minus 2 root 11 all over 4. So 3 plus or minus root 11 all over 2. So 3 plus or minus root 11 all over 2 solves 2x squared minus 6x plus 1 equals 0. Alright, now solve x squared minus 3x plus 1 equals 0. Discriminant first. And that would be 5. And thus it's 3 plus or minus root 5 all over 2. So 3 plus or minus root 5 all over 2 solves x squared minus 3x plus 1 equals 0. X squared plus x minus 1 equals 0. The discriminant is five, and thus we get minus 1 plus or minus root 5 all over 2. So minus 1 plus or minus root 5 all over 2 solves x squared plus x minus 1 equals 0. So 5x squared add 8x add 2 equals 0. Discriminant first. That would be 24. And thus we have minus 8 plus or minus root 24 all over 10. So minus 8 plus or minus 4 root 6 all over 10. Or rather, minus 8 plus or minus 2 root 6 all over 10. And thus minus 4 plus or minus root 6 all over 5. Minus 4 plus or minus root 6 all over 5. Trying to solve. Five x squared plus 8x plus 2 equals 0. Right. Okay, next up, the discriminant and nature of roots. (16). Find the discriminant of 2x squared minus 5x plus 1 equals 0. No, that's wrong. That's wrong. Find the discriminant of 2x squared minus 5x plus 1. The discriminant is b squared minus 4ac. And in this case, a is equal to 2, b is equal to negative 5, and c is equal to 1. And thus we have (17) as the discriminant. So 17 is the discriminant of 2x squared plus 5x minus 1. Next. No, that's wrong. That's wrong. 17 is the discriminant of 2x squared minus 5x plus 1. Okay. State how many real roots x squared plus 4x plus 7 equals 0 has. We apply the discriminant, which is b squared minus 4ac, and thus we do 4 squared minus 4 times 1 times 7, which is 16 minus 28, which is negative 12, and thus it has no real roots. X squared plus 4x plus 7 equals 0 has no real roots. Find the values of k for which x squared at kx at 9 equals 0 has equal roots. Alright, so that would be the case if it is the square of x at 3 or x minus 3, and thus the answer would be k is equal to plus or minus 6. So plus or minus 6 are the values of k for which x squared at kx at 9 equals 0 has equal roots. Find the value of k for which kx squared at 4x at 1 equals 0 has equal roots. Alright, so this would simply be 2, as 2x at 1 all squared is equal to, or rather, this would actually be 4, as 2x at 1 all squared is 4x squared at 4x at 1. So k is equal to 2. Yes, setting k as 2. Setting k as 2 is when kx squared at 4x at 1 equals 0 has equal roots. Find the range of values of k for which x squared at 6x at k has 2 distinct real roots. Alright, so we apply the discriminant. So 36 minus 4 times k. Hello. (36 minus 4k). That has to be positive. Alright, and so k has to be less than or equal to 9. It would seem. Right, let's just think about that a little bit more carefully. Find the values of k for which x squared at 6x add k equals 0 has two distinct real roots. So it only has two distinct real roots when the discriminant is greater than 0. And so we have to do 6 squared minus 4 times 1 times k. So 6 squared, rather 36 minus 4k has to be greater than 0. So 36 has to be greater than 4k. So 9 has to be greater than k. Alright, next up, sketching quadratic graphs. Okay. State the x-coordinates of the points where y equals x minus 2 times x plus 5 crosses the x-axis. That would be at negative 5 and 2. So negative 5 and 2 are where y equals x minus 2 times x plus 5 crosses the x-axis. State the y-intercept of y equals x squared minus 3x minus 10. That would be negative 10. So negative 10 is the y-intercept of y equals x squared minus 3x minus 10. State the coordinates of the vertex of y equals x minus 3 all squared plus 4. Negating 3 from the argument translates it 3 units to the right, and adding 4 translates it 4 units up, and thus the answer is 3, 4. So 3, 4 is the vertex of y equals x minus 3 all squared plus 4. State the equation of the line of symmetry of y equals x squared minus 6x plus 5. We apply minus b over 2a. So in this case it would be 6 over 2, which is 3. So x is equal to 3. So x equals 3 is the line of symmetry of y equals x squared minus 6x plus 5. State the coordinates of the turning point of y equals minus x squared plus 4x minus 1. Alright, so we apply the line of symmetry first, which is minus b over 2a, so in this case it would be minus 4 over minus minus 1, or rather minus 4 over let me think. It would just simply be 2. It would simply be 2. And then we need to only substitute this in. So it would be 2, 3. So 2, 3 would be the turning point of y equals minus x squared plus 4x minus 1. Alright, and lastly, we move to modeling. Ball's height h in meters after t seconds is h equals 20t minus 5t squared. Find the time at which it returns to the ground. So when it returns to the ground, the height h is equal to 0. So we need to factor out 5t. So we have h equals 5t open brackets 4 minus t. And then we can see that h is equal to 0 when t is equal to 0 or 4. So the answer is 4 seconds. For the same model, h equals 20t minus 5t squared, find the maximum height reached. As the two roots, as in when h is equal to 0, are t equals 0 and t equals 4, their midway point, i.e. t equals 2, is when the ball reaches maximum height after exactly 2 seconds. And so we need to only substitute in t equals 2. So we have 20 times 2 minus 5 times 4. And that would be 40 minus 20, which is 20. So 20 meters. So 20 meters is the maximum height of the ball whose height h in meters is modeled by h equals 20t minus 5t squared, where t is time in seconds. A rectangle has perimeter 20 centimeters. Find its maximum area. Alright, so there's no need for modeling this using quadratics, as clearly the maximum area is when it is most square-shaped, and conveniently it is most square-shaped when the perimeter is actually equal to 20 centimeters and the sides are all 5 centimeters. So I was asked what's its maximum possible area, and the answer is 25 square centimeters. Two numbers have a sum of 12. Find their greatest possible product. Find their greatest possible product. Well, again, this would be the halfway point. So 36. And last, a firm's profit P equals negative n squared plus 30n minus 50. So find the maximum possible profit. Alright, so if P is modeled by negative n squared plus 30n minus 50, then we find the line of symmetry, which is minus b over 2a. So it would be 15, and then we need only substitute 15. So we get minus 225 plus 450 minus 50. And that would be 175. So 175 appears to be the maximum profit if P is modeled by negative n squared plus 30n minus 50. And now we have to check. We have to check. Oh, wait. Okay. There's half an error there. Okay, that's fine. That's fine. Definitely not that one. Okay. Okay, so 1, 2, 3, 4, 5. So 5 errors, which is not good. 25 out of 30. So these have to be checked. So 2 or 4/3 for 5. And in exercise 12, we see that it's 3 plus or minus root 7 over 2. And in 19, we see that it's 4. 20, it has to be less than 9, not greater than it. And then 30, that one's just totally wrong. It has to be 15. So we have to check. All right. Okay, so question 5. No, actually, I got it correct. They're actually wrong. That's actually correct. All right, question 12. "36 minus 8 is 28, and that would be 2 root 7. Yep, so they're correct about that. Okay. 19. Alright, that's pretty obvious. That should have been 4. And this one. B squared minus 4ac has to be less than 0. No, greater than 0. So actually they're correct. So wait. "36 minus 4k, so 9 minus k, so 9 has to be Oh no, we're both correct. I'm just completely illiterate. Those say the exact same thing. Okay, and lastly, this one. So negative 30 over 2. So minus 30 over minus 2 is 15. And oh, yeah. Yep, okay. They were asking for the profits. No, sorry, they were asking for the value of n, which is presumably the number of months, and I gave them the profit instead. So it's just a misreading, that's all. All right. But that's good. I can move on now.